Are you fat because you're lazy and a sloth? Or are you fat because you're a glutton and you have gluttony in your life and you just eat too much? Do you have sloth and gluttony in your life? The two deadly major sins. Or are you suffering, if you will, a disease, right? Well, I can tell you, and you already know this, what society thinks. Society looks at you and says you have a moral failing, that you have no discipline, that you just simply cannot move the plate away. You make poor lifestyle choices. It's a lifestyle, it's a lack of willpower, that you're less worthy of a human being and that you're othered, right? And you see this everywhere. We see this in movies. We see this on billboards. We see it in social media, that, that thin kind of body structure is idolized, and, beauty and be thin, and this is the way to go. And that if you're fat, you're not as good as everybody else, right? So you end up with this incredible bias and stigma and discrimination, and it's just incredible. It's everywhere and rampant, right? But what if I were to tell you that there's more at play here? And of course, look, you're responsible for what you put on your plate and what you take in. You are responsible for what type of lifestyle you live. You're responsible. I mean, ultimately, you are you, and you've got to take care of yourself, and you have to take the onus of taking care of yourself. But what if I were to tell you that it's not completely your fault, and that there are other powerful factors which are at play here that you may have never heard about? And in fact, many doctors have not even heard about this. What if I were to tell you that there are billions of years of cellular biology which are at play here? Billions of years, okay? What if I were to tell you that there are 200 million years of human biology which are at play? 200 million years ago when the first humans appeared, right? What if I were to tell you that there's 435,000 years of Homo sapiens biology which are at play here, involved in the body weight that you have, in the adiposity that you have, the weight, the obesity that you're living? What if I were to tell you that you are living in a chronic disease state? Okay, so bear with me, okay? We're going to go through this and let's discuss this. That is it your lifestyle or is it a disease state? Now we know, I was just watching Joe Rogan, right? It's everywhere, right? They're talking about that 60 Minutes special on CBS where they were talking about obesity and all this type of stuff and whatever. And Joe Rogan and his Lex Friedman, they're just saying, well, look, you got to, in a sense, pull up your bootstraps and make a decision and change your lives and, do all of that type of stuff. So let's start this story and about this whole idea about obesity. Maybe it's a disease. Maybe you're living within a disease kind of process. So it starts in 1840. This is incredible, right? So doctors are studying these patients, and these patients are massively obese. They've got this incredible voracious appetite, and they just can't stop eating. And by the way, look, I'm not talking about the downstream effects of obesity. I'm not talking about the stuff that occurs as a result of the obesity, like, the diabetes, like we talk about diabetes, right? Because obesity and diabetes, they're closely related. I'm not talking about the strokes and the heart attacks and the angina and the kidney disease and the retinopathy and the eye disease and the blindness and the sudden death and all that type of stuff, or the, DVTs and the pulmonary embolisms and the sleep apnea. I'm not talking, those are downstream effects of the obesity, which doctors have recognized way back in the time of Hippocrates, right? He talks about that. Sudden death in people who are living with obesity. I'm talking about is obesity and that weight in and of itself more than just a lifestyle choice, but a disease? So the story starts in 1840, right? So these patients are so obese and they just don't stop eating no matter what you do, and they're going to garbage cans and taking banana peels out and eating, whatever they can find in the garbage even, right? So the doctors find out that these patients, they actually have hypothalamic tumors, right? Now, by the way, I'm not telling you that, oh, you have a hypothalamic tumor and that's why you're obese and living with obesity. I'm not telling you that at all. Don't take that at all from what I'm saying. That's not what I mean at all, okay? All I am saying is that these patients have had hypothalamic tumors. And so doctors in 1840, so, a couple of centuries ago, they say that, well, you know what? Maybe the hypothalamus seems to be integral in terms of body weight. It has something to do with body weight and regulating body weight. So that's the first step. Now we're going down, so bear with me because it's a story about the disease of obesity. So they say, okay, well, the hypothalamus has something to do with it. It regulates your body weight. What's the next step of the story? So now we're at 1949, okay? So now researchers are studying mice and rats, right? And poor rats and poor mice, because they are just absolutely brutalized, right? In medical studies and in research. It's really, it's really sad. I mean, if you're an animal lover, but it's just brutal what is done to them. And you don't see what is done, but it's really incredible what is done. And so in any case, that's another subject. But in 1949, so they're studying these mice and rats. 2 strains of mice and a strain of rat, which are massively obese. Same sort of idea that they can't stop eating. They keep eating and eating, voracious appetites, no matter what you do. And so these rats and mice are just really, really fat, okay? Mutant mice, if you will. And forgive that term, but just calling it for what it is, right? So the researchers are trying to figure out, like, what's the cause of it. So they study the cells, okay? And cells, they have chromosomes, and in the chromosomes are what are called genes, which are made up of these double strand helix DNA strands, right? It's so beautiful and deep, and it's incredible, right? But they find that there are genetic abnormalities in these 3 strains, the 2 strains of mice and 1 strain of rat. And so they call the first strain the OB strain, okay? So OB standing for obesity. The second strand of mice called DOB standing for diabetes, right? And we know that obesity and diabetes are related, diabesity, right? And the third strand is a mouse. They call it a rat. They call it the Zucker rat, right? And they call it the fatty rat, okay? So you got these 3 strains, but they're wondering, like, okay, what do these genetic abnormalities, okay, have to do with obesity? Okay, so they're trying to figure it out. In the 1970s, so now there's the next step in this whole idea about obesity being a disease. They call it the Coleman studies, right? They figure out that those genes in those 3 strains must be coding for a protein hormone that is an appetite suppressant. Basically, if you have it, it makes you not want to eat. And if you don't have it, you just will eat and eat and eat. But they didn't know what particular. So that was the theory at that time. So we're talking about the 1970s, right? So they don't know what it is, but that's the theory. Then the big breakthrough came in 1994, okay? Rockefeller University in the United States of America, in New York, at that university, they discovered exactly what that protein was. Can you guess what it is? Okay, so let me get my surprise guest here, okay? So I don't know if you can see this, okay? It's called leptin. Leptin. This was what it was. And so leptin is from a Greek term which stands for leptos. Leptos means thin, so they called it leptin. So now they figured out, okay, well, where is this leptin coming from? They found it was coming out of the cells, the adipocytes. And keep in mind, this is not even really that long ago. This is 1994, right? So a lot of doctors haven't even heard about it. And it's incredible because I talk to doctors as well, and they've never heard about leptin and what this is. And it's incredible how fascinating it is, because if you look at most of what we see in medicine today, you won't even believe it that a lot of these are downstream effects of this adiposity of the fat that people are putting on. And you know, I talked about, you know, the bias and the stigma and the discrimination, whatever. Well, you know, you're not alone, because 73.5% of people are overweight or obese, right? So it's everywhere. You see, you just go to the grocery store, go to whatever it may be, you go to Costco or whatever, you know, department store you want to go to a movie theater, go no matter where you see, it's everywhere, right? And look, frankly, I'm going to be very frank. You go to doctors' meetings, it's the same thing. It's not like doctors are immune. You see easily 70%, 60, 70, 75% of doctors who are also overweight or obese, right? So it's not, you're not alone, okay? It's like everywhere. So think about that. So they figured out that the leptin was being secreted by fat cells. Now, before we used to think that fat cells were simply storage cells, that they're inert. They don't store water, and that they store what are called triglycerides. So they're just fat storage. They're just a storage unit inside the body. But it's my goodness, it's so much more complicated than that. The fat cell is a beautiful integrated endocrine organ, right? It's incredible. They have discovered more than 600 cytokines and adipokines and immune factors which are being secreted. These cells, the fat cells, they are communicating. It's incredible. They are communicating with your heart. They are communicating with the endothelial lining of the heart. You know, the coronary arteries that we talk about that get blocked, right? They're communicating with your kidneys, with your eyes, with your entire body. It's incredible. With the liver, with the pancreas. It's like really incredible, right? So they found that the leptin, which we were talking about, that big breakthrough, it was being secreted by adipocytes, okay? So I hope you're following along, because there's a lot of science here, but this is really, really fascinating, okay? And basically, if you don't have leptin, then you're gonna gain weight and you're gonna have this massive appetite, okay? So now what we've established at this point of this video is that you have two components when it comes to human body weight. One is the hypothalamus, and number two is leptin. But the story here in 1994 is that although they had identified leptin, they never saw it in human beings. So it's like, okay, well, where are human beings who have this disorder? And does everybody have this disorder? And what was also fascinating about leptin is that it seemed like, at least in the animals, that the more fatter, you know, they got, there was more leptin. Anyway, I'll get into that in a second. So now we go a few years later, in 1997. So again, this is not really that long ago, right? So that's when another breakthrough came in, okay? So they discovered, so this is in Pakistan, in Pakistan. So there's a lot of, you'll find certainly consanguinity, right? Where you have cousins who marry cousins, right? It's a common thing, okay, over there. So they found in one grouping, in one family, where you had this consanguinity, okay, where you had cousins marrying cousins, that they found a family where there were people with this massive obesity, right? Living with this massive obesity. So they tested them, and lo and behold, what did they find? That these people had no leptin at all in their blood. And they found that the exact same genetic abnormality which was found in those mice, the same genes there was a genetic abnormality in the exact same genes. the OB gene. So they still call it in human beings too, the OB gene, okay? No leptin produced. Genetic abnormality. What was incredible now? Now, look, medicine sometimes has spectacular failures. Spectacular. Where, you know, they're the most horrible things, right? So sometimes you see this stuff, you can Google all of this stuff, right? Where evil surgeons operating on human beings and taking out organs and doing the most, you know, horrible things, right? Even in, you know, popular media, you see this, like the human centipede, like these horror movies where people are talking about, okay, how do I join human beings together? And, you know, just horrible stuff, right? Spectacular failures in terms of medications. You know, you start giving doctors or prescribing medications, like, for example, opioids, right? Where doctors were prescribing opioids and more opioids. Suddenly there's the opioid crisis. And you see so much fentanyl death and overdose and whatever, which everybody is touched with now, right? Spectacular failures. But you also see spectacular successes as well. And so in these human beings, so we're back at 1997. So what did the doctors do? The doctors said, well, okay, well, there's no leptin. There's a genetic abnormality. What if we give them leptin? Okay, and inject human recombinant leptin. Let's create it in a laboratory and give it to them. That's exactly what they did. And you know what happened to those people? Incredible weight loss. Incredible. They became thin. It was unbelievable. It was incredible, the results, okay? Basically, you cured them, okay, of their obesity, okay? Let me get to that point about the, you know, the more fat you have, the more leptin you have. Well, look, does it make sense, right? So the more fat tissue that you have, the more leptin you'd have, right? Because if there's more leptin, then it tells you, okay, don't eat because, you know, you're too fat, you're too obese. So it makes sense. And if you have a very little amount of fat, then it makes sense that leptin would be very low. Okay, so now, so we've established the hypothalamus and we've established leptin. Okay, so now this is where we're at the story. Okay, but is there a relationship between the hypothalamus and leptin? And it turns out, so this is now the next incredible discovery, is yes, there was a connection. In fact, leptin was acting at the level of the hypothalamus. And what they found in the hypothalamus, it's incredible. There's a part of the hypothalamus, it's called the arcuate nucleus. The arcuate nucleus. Okay, I'm going to show you a thing here. Look, it's a busy kind of a thing here. Okay, but hopefully you can kind of get an idea of what I'm trying to see. So you see these two pathways. Here's one pathway, and here's another pathway. Okay, this pathway, called the POMC CART pathway in the hypothalamus. Basically, if you stimulate this pathway, you end up with appetite suppression. Your appetite goes down and your energy expenditure goes up. And you start to lose weight. And so what they found with leptin is that pathway, the weight loss pathway, if you will, was being stimulated by leptin. But what else did they find? They found that there was another pathway in the hypothalamus. It's incredible. The other pathway was called the weight gain pathway, the fat pathway. Believe it or not, it's there. It's there in the hypothalamus. That's why I was talking about these billions of years of cellular biology, the 200 million years of human biology. Just think about this. It's incredible how complicated and complex. And believe it or not, look, doctors, maybe people think, oh, doctors know a lot. Believe it. Believe you me, okay? I am a doctor. I'm a medical doctor myself, okay? We know very little. There's very little that we know. Very little. And there's so much more to be discovered. It's so complex, the human body. But let me continue with the story. So they found another pathway, the weight gain fat pathway, okay? The agouti-related peptide pathway, neuropeptide Y, okay? So this was the second pathway, agouti-related peptide and neuropeptide Y pathway. And again, you know, this, maybe you've never heard about this, but this is why I'm putting out these videos. So neuropeptide Y is the most powerful thing that we have discovered till now that makes you want to keep eating and eating and eating and basically just sit on your couch and watch TV and watch social media. It's neuropeptide Y. It's so powerful, right? That was the weight gaining pathway that we found. So basically when that pathway is stimulated, your appetite goes up and your energy expenditure goes down. It goes down. And so you gain weight. What was leptin doing? Wow. So leptin was stimulating the weight loss pathway, the POMC cart pathway, and it was putting a brake on the weight gain pathway. So you're ending up with weight loss. And so it was incredible. But it was incredible, the discoveries which were coming afterwards, right? So that now they started discovering more and more hormones, okay? So there's another key hormone which I want to talk about, okay? Ghrelin. Ghrelin, what is that? What is ghrelin? So if you, I think I'm pointing to it right there, okay? So forgive me if I'm on the wrong thing. Am I pointing to it? Yeah, I'm pointing to it, okay? What does ghrelin do? Ghrelin is that hormone, you know when you don't eat and your stomach starts to growl? That's what it is, ghrelin. Ghrelin stimulates the pathway of weight gain. Your appetite goes up. You feel that stomach growling and you just gotta eat. And it decreases your energy expenditure. And by the way, if you wanna know what ghrelin is all about, right? So there's a syndrome, I'm going to talk about it in a second, it's called Prader-Willi syndrome. These patients who have Prader-Willi, they have massive levels of ghrelin, right? So the ghrelin is that also, this is the second most powerful after neuropeptide Y, which I just talked about. So ghrelin, you've got too much of it, your appetite just goes up, and it's incredible what ghrelin does, right? Because these things are so much more complicated and complex than people can imagine. It's incredible, the human being. So what ghrelin actually does is it also increases your visual spatial intelligence, if you will. So you're able to forage more and you can look around and see where is food. So, you know, I was just reading an article, you know, because in the New York Times, it's called What New Weight Loss Drugs Teach Us About Fat and Free Will. So it's written by Julie Bellows, I guess that's her name, right? And she talks about a patient with Prader-Willi syndrome, right? In England. So what do these patients do, right? So you've got to lock your kitchen, okay? Or you've got to put a door on your kitchen and put a code on it so they can't get in. You've got to actually put a lock on your refrigerator. And you won't even believe you have to put a lock on your garbage because they'll go in to try and get it because of all that ghrelin, okay? So we've established the hypothalamus, we've established leptin, and now we're talking about ghrelin, right? So ghrelin stimulating that weight gain pathway. But what else happened? So this is incredible, right? They kept studying this pathway, the weight loss pathway, and so they found other things that go down the pathway of weight loss in the hypothalamus, other elements, if you will, okay? So you got here, and okay, what am I pointing you? Okay, right here, okay? So you got this thing here, the alpha melanocyte stimulating hormone, and you got this MC4 receptor, right? See, MC4 receptor, that's what I'm pointing you. So they found that there's a whole bunch of other hormones, okay, that actually interact with this weight loss pathway in the hypothalamus. There's much more, right? So you've got the leptin that we were talking about. But you've also got these other things. Okay, look at this, right? So remember, first of all, remember the MC4 receptor, okay? But now look at this, GLP-1, okay? Think about that. I'm going to talk about it in a second. Cholecystokinin, CCK, peptide Y, right? What's that? Amylin, what's that, okay? So they found all these other things that are interacting with the weight loss POMC CART pathway, okay? So you just saw what I was talking about, right? The GLP-1. So what are researchers and doctors going to do? They're going to say, well, look, and by the way, these hormones that I'm talking about, like GLP-1, right? Glucagon-like peptide 1, right? So they're released by the gastrointestinal tract. So you eat something, and then your GI tract, you know, the L cells, as they call them, are going to release GLP-1. You're going to get oxyntomodulin, which is going to be released. You're going to get cholecystokinin, which is released from the pancreas, the amylin. So you get all these things which are released, which basically all of these things, it's really incredible. And there's a lot of redundancy. Well, you know, when I was studying this, they say there was this natural redundancy in all these different pathways and the vagus nerve and whatever. But it's not really redundancy. Like, nature isn't stupid, okay? Or if you want to call it, in whatever way, whatever your belief is, right? The human body is not stupid. It's incredibly complex. Every single thing that is there has a specific purpose of why it's there. It's specifically there for a reason. So what do all these things do? So what are doctors going to do? Okay, so you got this GLP-1, and okay, well, why don't we try to create GLP-1 and inject more of it, okay? Or alter it, because GLP-1, so you know, you eat a meal and you get GLP, glucagon-like peptide 1, which is released, but it's degraded very quickly. So it's what's called an incretin, right? So it stimulates insulin, and it's degraded by DPP-4, okay? So it gets degraded very quickly, okay? So they said, well, why don't we alter it a little bit so that it lasts for a long time? And lo and behold, that's what they did. The first generation liraglutide they created, okay? So they created this. And lo and behold, they said, well, what if we give this as an injection on a daily basis? Will people lose weight? They call it, the trade name being Saxenda, and lo and behold, yeah, there's weight loss. But what if you change it more so it lasts even longer? So this is what drug? What drug are we talking about? GLP-1 agonist. They call it an agonist because it's stimulating that, it's simulating GLP-1 and it's stimulating the weight loss pathway. It's called semaglutide. And the trade name being Wegovy or Ozempic. That's what everybody's talking about, right? So they're talking about, the Kardashians are taking it, Elon Musk, famous people, Hollywood actors, people who are not even overweight or obese are just taking it, they want to inject themselves so they can lose a little bit of weight for their party and whatever. And so now there's shortages for people who actually need the Ozempic for diabetes. There are shortages, everyone's taking it. Why are they doing it? Because it's a GLP-1 agonist, and like the leptin that we are talking about in the stories of the rats and the mice, it also stimulates the hypothalamus, the weight loss pathway, and people start losing weight. Now there's another drug, right? Tirzepatide, right? Mounjaro, right? Which people are taking, which is a dual agonist. So I talked about GLP-1, I talked about there's something called GIP. So why don't you put them together, inject it, and what happens? Massive weight loss. So let's continue the story. Now, I wanted to just go back to this, okay? So remember we were talking about that weight loss pathway, and, take a look at that MC4 receptor, okay? So now doctors and researchers started finding, because the whole subject of this video is that, is obesity a lifestyle choice or is it a medical problem, okay? And this is part one. So they found that MC4 receptor, that deficiencies or abnormalities or genetic abnormalities, first of all, it's a lot more common than you think. It's really incredible that in fact now most cases are missed. They're not seen actually. They're just simply, they go undiagnosed. So you see people who are generally, they're very tall, very big. People call them big boned, lots of obesity. You see a lot of that, right? MC4 receptor deficiency, right? You can, by the way, genetically test for it. It is testable for now. So they theorize that, 4 to 7% of infants and babies who are born with get really big and fat, right? That 4 to 7% of them have some sort of genetic abnormality, and the most common of those being this monogenetic cause of MC4 receptor deficiency. Well, can you give a drug that stimulates that? Yes, you can. And so we have a drug which is now, it is FDA approved for that pathway, right? So POMC deficiency or leptin receptor deficiency called setmelanotide, okay? So you can see, so the point I'm trying to make here is that, so now you're seeing, this hypothalamus, you're seeing these hormones, you're seeing the connection between the hormones and the hypothalamus, and you're seeing the relationship to the weight. So they discovered these monogenetic causes of obesity, like MC4 receptor deficiency, leptin deficiency, leptin receptor deficiency, POMC deficiency. They're discovering, this is a while ago, right? Prader-Willi syndromic causes of obesity, right? Syndromic causes like Prader-Willi, where you get these, you just get this massive surges of continuously high ghrelin. But you're also finding, okay, now this is where we start getting into what we're talking about, the 60 Minutes special on obesity, which actually spawned lots and lots of controversy, right? So you had Leslie Stahl, 60 Minutes CBS, okay? And you can just Google it and you can see it, right? So they had Dr. Fatima Cody, right? And they had Dr. Apovian. These are well-known doctors in the obesity circles, right? So who I respect very much, but they had them there. And so they talked about the whole idea about what's happening in obesity and what's happening there. And so we start getting into another aspect of obesity, okay? So we talked about the monogenic, the syndromic obesity. Wow. They started studying what are called genome-wide association studies, where they're studying the human genome and studying that are there genes that have a relationship with body weight. And sure enough, it's incredible from these genome-wide association studies that they've discovered now more than 1,000 genes, okay, in the human genome, which are associated somehow with body weight, okay? With body weight. The classical one is called the FDO gene, which is on chromosome 16, okay? So if you have it, if you inherit this, right? So you're going to be bigger and fatter and more obese than if you didn't have it, okay? So you have all these genes, so what they call polygenetic obesity, okay? So, going more deeper into this, what does that mean, this polygenetic obesity, okay? Well, just like Dr. Fatima was saying, and she was talking to Leslie Stahl about this whole idea about what are you seeing, like 73.5% of people are overweight or obese. Like, what is this, okay? So if you study twins, right? And you separate the twins at birth. So they studied this in Sweden. There's other studies like this, twin studies of obesity. you put one twin in one family and another twin in another family, right? You will see that one twin ends up becoming obese and has a certain family that they're living with, but the other twin is also obese, living thousands of miles away, even though the family is completely different. So they said, well, there's obviously some kind of genetic thing which is going on, right? And so you also see, for example, that, if your parents are obese, if both parents are obese, it's like an 80% chance you're going to be obese, right? So basically, this was the argument which was being made by Dr. Fatima Cody that, look, it's not people's fault, and, try to understand what people are going through, and, they're living with this type of thing, okay? Let's continue. And so now we're talking, so we've got this idea about, okay, well, you've got the hypothalamus, you've got these hormones, you've got this leptin, you've got these GLP-1 agonists that, can lead to body weight. But what about the medical community? Okay, are they going to call it a disease, and when are they going to call it a disease? So this was really incredible. There was, they call it a pivotal study in obesity medicine, which actually occurred. And again, this is really not long ago. We're only talking about 2011, okay? Where Sumithran, so this is published in the New England Journal of Medicine. This is like it's a fascinating study, okay? Fascinating study in which Sumithran, okay, studied 50 people, okay? And what he did was that he put them, so him and his group actually. So, by the way, the title of the study is called "The Long-Term Persistence of Hormonal Adaptations to Weight Loss." Okay, long-term persistence of hormonal adaptations to weight loss. New England Journal of Medicine, 2011, Sumithran. Okay, so basically, what they do with these patients is that these 50 patients, they put them on this really, really low calorie diet, okay? So they give them 500 to 550 kilocalories for 10 weeks so these patients lose weight, okay? They lose weight. Then they see what happens to them, okay? And they do blood tests and whatever, okay? This was a pivotal study, okay? So just bear with me, okay? So basically in this study, this group is studying ghrelin, what happens to ghrelin, okay, after the weight loss, and what happens after that weight loss. They studied amylin, which I talked about, right? So remember, ghrelin, it interacts with that weight gain pathway. It tells the part of the hypothalamus for weight gain weight, right? So it's very powerful, right? Amylin, it said, okay, we're going to study amylin, see what happens to amylin. Which again secreted from the pancreas, it tells you to lose weight. What happens to peptide YY, again released by the gut, tells you to lose weight. What happens to cholecystokinin, CCK, which also tells you to lose weight. And interestingly also, Sumithran and his group, they also wanted to see what happens to what you feel, like your desire to eat and your hunger, okay? Like what's gonna happen to that, okay? And the other thing which was really fascinating is that he studied also, or that group, they studied what happens to your body weight. Like you lose the weight, 500 kilocalories of a diet, you get your weight down, does the weight stay off, or what happens, okay? So this is fascinating. So here we go, okay? So again, this is a bit of a busy thing, okay? But let's take a look at it, okay? So first of all, what happened? Okay, and by the way, so they test all of these things at baseline and at 10 weeks and at 62 weeks. So they're doing this, they're following these patients on for 62 weeks, what happens? So this is what's amazing, okay? Right? So let's look at the first thing. What happens to ghrelin? Wow. What happens to ghrelin is that after you lose weight, and even at 10 weeks and 62 weeks, the ghrelin remained higher than before you lost the weight. It was just higher. And even at 62 weeks, okay, it was high, meaning that this hormone ghrelin is too high and it's stimulating after that weight loss for you to eat more, even at 62 weeks. Okay, what happened to peptide YY? Okay, what happened to peptide YY? Here it is, okay. Wow, what happened to peptide YY is that instead of being high after eating postprandially, it was lower than what it had been before. It was low. So peptide YY after you eat, normally it tells you don't eat, right? It stimulates that weight loss pathway. It was low. It was low at 10 weeks. And lo and behold, it's low at 62 weeks. And the same thing happened with amylin. It's low at 10 weeks. It's low at 62 weeks. Wow, same thing happened with cholecystokinin, CCK. It was low at 10 weeks and 62 weeks. Oh my God, what happened to this? Now, anyone who has tried to lose weight, okay, this is like incredible, okay? You look at what happened to hunger. People were hungry. They were hungry at 10 weeks, at 62 weeks. They were just hungry, okay? Hungrier than before, okay? What happened? So this is, again, these are studies postprandial. So you give the subjects, the patients food, and what happens after that, after that meal. What happened to the desire to eat, the hunger? It was higher. So patients had this, even when they ate, they didn't feel like they were full, okay? And so Sumitran was able to show in that study published in the New England Journal of Medicine that you've got these persistent hormonal adaptations that occur after you lose weight, okay? That study was a kind of one of the pivotal studies where doctors said, you know what? This really is showing that weight and obesity, it's some kind of disease. Okay, it's some kind of disease. And so what happened is that the American Medical Association, so again, look at how recent this is. In 2013, they said, we're going to call this a disease. At their council of delegates and however they do things, they called it a disease. If you want to look up in Canada in 2015, they called it a disease. They labeled it as a disease in 2015. They said it is a disease state. Obesity, being overweight and being obese is a true disease. Okay. Now, what do you mean it's a disease? What is the meaning of that? Okay. What are the implications of all this stuff we're talking about, the hypothalamus and these hormones and the interaction on the hypothalamus and these polygenetic studies and these twin studies and the soaring rates of overweight and obesity which we see today? That what are the implications? What does that mean? What does Sumitran's study indicate? Okay. Why is it a disease? What do you mean? Okay, I'm going to explain. This is the crux of everything I've said today. It means that somehow the body has a set point for your body weight. Okay? They call it a set point. And the hypothesis, the thought is that set point is in the hypothalamus of the brain. That's what the thought is. And that set point is like a thermostat, okay? So I'll give you an example. So let's say, it's really cold in the Northeast right now, freezing temperatures right now, okay? Now let's say you set your thermostat down, right? So it's freezing cold. What are you gonna do? Okay, so, well, why don't I bring in some heaters and turn on the heaters and you turn them on, you say, okay, so now it gets nice and warm, okay? You turn the heaters off and you say, oh, it's nice and warm. What happens? It becomes freezing again because the thermostat is set low, okay? Or we can talk about the other way. Let's say you set your thermostat really high, okay? And then you bring in like air conditioners and you try and make it cooler, and then you turn the air conditioners off. What happens? Temperature goes back high because the problem is the thermostat. It's too high. So basically everything I've said and the Sumatran studies was showing that somehow the body has a set point for body weight, or more specifically adiposity, and the body is somehow defending that set point. And that even if you try to lose weight, your body will defend the set point and try to force you to regain the weight again. And that's, part of that, if you look at this graph here, is that you see this plateauing of body weight, right? So people lose weight, and around the 6-month mark, it doesn't matter what you do. And believe you me, it's incredible. It's the same thing if you do bariatric surgery. People plateau, and then the weight starts going back again. So bariatric surgeons, what they say is that, okay, well, we'll do bariatric surgery, try and get that weight off, do a Roux-en-Y bypass and whatever, and the weight's going to come off and whatever. Well, what happens? Certainly not everyone is successful. People regain the weight. Same thing with drugs, right? You end up with some kind of plateau at some point in time, and then somehow there's some degree of what they call tachyphylaxis, where the drug doesn't seem to work anymore, and the body weight starts coming back. I was watching, Vance's amazing journey, right? Or, what he did, I guess he was like 400 pounds plus, right? He loses a massive amount of weight, right? So I was trying to see, okay, has he actually kept the weight off, right? And so I found, more recent videos from a couple of weeks ago and whatever. And unfortunately, he's put on a lot of the weight again, right? So now he just weighed himself, I think, a couple of weeks ago. And now he's back to 300 something plus pounds. And, he's had 2 knee replacements. And by the way, look, one of my fields is sports medicine. I'm diploma of sport and exercise medicine, right? Is like, my goodness, man, what does the weight do? That extra weight, I showed you that 5-pound model is that weight. It damages your joints, that day in, day out walking and the joint damage that occurs, right? He had 2 replacements and the other one, I'm going to talk a lot about the Biggest Losers game show contestants and what happened, and the Kevin Hall studies and, the weight gain. But any case, the point I'm trying to make is that for some reason, there is a set point that is held in the hypothalamus, the body weight set point. So let's say, you get up to like 350 pounds, right? It's not uncommon today. 300 pounds, 350, it's just not uncommon anymore, right? So, and let's say your ideal weight should be like 180 pounds or 160 pounds or whatever, right? And let's say you lose weight. What happens is that, you'll lose weight, but then that thermostat, that hypothalamic set point is set. So let's say you get down to 180 pounds and you're 350 pounds. That hypothalamic set point was set at 350 pounds. And that hypothalamus and, those hormones are just going to force you to regain that weight. It's going to do whatever it can for you to get that weight up. Now, okay, so we've set we're talking about the set point. And so now, okay, well, can you cure the set point? So let's talk about, Ozempic, right? Or Wegovy or semaglutide, right? The stuff that people are injecting every week, okay? Okay, does it actually cure the actual source of what is going on in terms of the weight and the obesity? Well, they've done the studies, right? So the STEP studies and the step 1 trial extension studies, what happened? So they stopped the drug and said, okay, what happens? You know, no surprise, the weight just came aggressively back on, just aggressively back on, because that hypothalamic set point was not reduced. It was just wherever it had been before, like didn't get the actual set point to come back down. I'm talking to, bariatric surgeons, right? So bariatric surgeons, one of the things that some bariatric surgeons say is that, well, you know, the advantage of doing bariatric surgery is that it reduces the hypothalamic set point. But look, I mean, it's pretty hard to believe that, especially when you see these plateaus and the number of people who actually fail bariatric surgery and regain the weight, you know, et cetera, et cetera. But that's for another video. I'm just talking about this whole idea of set point. Okay, now I'm coming to another point about this set point. So we've established this thing about the hypothalamus and, you know, these hormones and this set point, and it's set high. And because it's set high, you know, it can't be healthy to have all that extra weight, because we know all the downstream effects. Any doctor knows it. Anyone who deals with people knows, you know, the downstream effects are bad. Hippocrates has demonstrated this, you know, way back, you know, 300 BC, 350 BC, etc., right? So they documented this, right? That, yeah, there's downstream effects to this weight, okay? So it can't be healthy to have this. So why would your body want to do this? So basically, now here is where we are in 2023. Some doctors and researchers say that set point, like let's say now we're in the kind of getting to the tail end of this COVID, hopefully, right, situation, right? They say the set point has gone up even more, and that set point is a permanent disease and you're stuck with it. And it doesn't matter what you do, you're just stuck with it. It's a disease state. And so they've done studies, they talk about gliosis and tanocytes in mice and rat studies, that, you know, you see these actual changes in the hypothalamus, which people say are permanent. You're just stuck with it. And you can't put it into remission and you can't cure it like type 2 diabetes. You're stuck with it. Personally, myself, I don't believe that, and I don't want to subscribe to that at all. I actually do believe that the majority of people, in fact, you can probably reset that hypothalamic set point. I'm going to talk about that in future videos, which is really the cure, because the body is incredible. The human body is incredible. If you just give it a little bit of TLC and common sense, okay, I believe we can actually address it, but we'll talk about that on another video. But a lot of doctors don't believe it. They think that it's a ratcheting type thing, that you just ratchet it up and you can't do anything about it, and you're stuck with it. You have a chronic disease, accept it. You know, you should be on lifelong treatment. So I'm talking about 2023 today. This is where, this is where you saw the 60 Minutes interview, and you saw all the backlash which came, and people say, what are you talking about? And, you know, you can't, go to diet and exercise and whatever. Okay. So now I'm going to add one more thing. Okay. All these studies and Biggest Losers, look, there were studies done way before which showed this whole idea, the Sumithran studies in 2011, they showed the same thing, okay? This is like really incredible. So one doctor, his name is Dr. Ansel Keys, okay? So in 1944, he did what are called the Minnesota starvation experiment, okay? So this was like really a really, fascinating study where he had these people who refused to go to war. So they were called conscionable, I don't know, whatever the term is. Like they just said, I'm not going to go to war, okay, in 1944. And so basically what he was trying to do was Europe was undergoing starvation because of the Germans and whatever. And so he was trying to see, well, everyone in Europe was basically undergoing this starvation. They didn't have very much food. They were eating turnips and whatever. So how are we going to reintroduce foods to the starving European population after getting rid of Adolf Hitler and ending the war in 1945? What are we going to do? So they took these 36 people. These people were eating a caloric diet of something like 3,200 kilocalories per day. They put them on 1,800 kilocalories per day. What happened to these people, right? Their energy expenditure plummeted. They were completely, they couldn't stop thinking about food. They drew food. They were miserable. All they could think about was eating. They were also made to march and all this type of stuff, right? So he saw this, this decrease in energy expenditure and all these type of stuff that I'm going to talk about in a separate video, right? So they found that the leptin plummeted, the energy expenditure plummeted, the thyroid hormones T3, T4 plummeted, and so they saw this stuff. Okay, set point up. You can't change it. You're stuck with it. You have a lifelong disease. There's no real remission. There's no real regression. There's no way of curing it. You have to take medications. It's a lifelong treatment and whatever. Okay. Everything I've talked about in this part is a part of the brain called the homeostatic part of the brain. If you will, the lizard brain, although it's not really the lizard brain because that's the medulla oblongata and whatever, but just bear with me. I'm going to call it the lizard part of your brain, the homeostatic part of your brain that, all this leptin and this and that interacts, okay? Now I'm going to introduce the subject that I'm going to talk about in my next video, okay? There's another layer of the brain, okay? It's called the hedonic limbic system of the brain, okay? And this is where we talk about dopamine and pleasure. It's the pleasure part of the brain, okay? So now we've talked about the homeostatic. We're going to talk about in the next video about the hedonic pleasure part of the brain. Now this is where I'm going to differ with some of my colleagues, and I know there's a lot of doctors that think the same way as me. Okay, the hedonic system is different. This is where you feel pleasure. This is where you take cocaine or drugs and whatever, that part of the brain lights up. Dopamine, pleasure, and whatever. What part does the big food companies in America have in this aspect? What part do the department stores and the food companies and the fast food restaurants have in this part of the brain? Human biology, the pleasure part, okay? What they call the bliss point, which is research when food is made. What part do they have? What part do the food companies and the soft drink companies and all these companies have in this hedonic part, pleasure part of the brain, essentially in exploiting child biology and human biology? What part does it have in the obesity, overweight crisis which we are seeing? That's what we're going to talk about in the next video. We've talked about the homeostatic layer. We're going to talk about the hedonic layer. And in the next video, I'm going to talk also about the third layer of the brain called the executive layer of the brain. Okay? And it's going to blow your mind. It's just incredible, okay? This whole biology and how it ties into what we're seeing today. And can we do something about it, which is the bottom line, and actually work on that set point. Hope you join me in this fascinating journey, and see you later in the next video.